So, hello guys, this is Dr. Edwards again. I want to give some suggested solutions to the exercise assignment for the first part of Chapter 13. On this occasion, I will read the question as given, and then I'll give some verbal statements that will help you write out your answers as you submit the exercise questions to me. The first is, why are there more carbon compounds than compounds of any other element? Why are there more carbon compounds than compounds of any other element? That is an important question, and it stems from the fact that carbon has 4 outer electrons in its outer subshell. There are 4 of these p electrons. Therefore, carbon will bond readily with other atoms and combine readily with other carbon atoms. So each carbon atom will bond readily with another carbon atom or with other bonds. So the mere fact then that it has those 4 electrons, it can readily bond with other atoms. That's the answer to that question. Why are there more carbon compounds than compounds of any other element? Number 2, in what ways do organic compounds as a class differ from inorganic compounds? As we've said, organic compounds must contain the element carbon. So all organic compounds contain carbon. Inorganic compounds do not in general contain carbons. And furthermore, organic compounds also often have hydrogen. So that covalent hydrogen bond is present, and that's a distinguishing feature between organic compounds and inorganic compounds. So let me say it again. Inorganic compounds do not have carbon, but organic compounds, all of them, must contain carbon. And it contains carbon with the covalent bonding of carbon to other atoms and or bonding carbon to other carbon atoms. That's the answer to that question. Number 3, what is the principal bonding mechanism in organic molecules? I've already stated it. It is the covalent bond. The covalent bond compared with ionic bond or metallic bonding, no, none of those exist when it comes to organic compound. It is the covalent bond, covalent. The covalent bond is the predominant bonding mechanism in organic compound. Number 4, how can the different alkanes in petroleum be separated? That's the main part of the question. I'm not worried about the next part. So if you think about all of the alkanes, let me run through the first few of them again for you. There is methane, there is methane, butane, propane, ethane, pentane, hexane, heptane, octane, and nonane and decane. Let me name them again. Methane's first, then ethane, propane, butane, and pentane, heptane, hexane, octane, nonane, and decane. All right, so those are they. How can you then separate the alkanes? You can separate them with temperature change in a distiller tower. D-I-S-T-I-L-A-T-I-O-N, tower, T-O-W-R. So the distiller tower has lower um, temperatures in the high part of the tower, but lower temperatures, higher temperatures in the low part of the tower and lower temperatures in the upper part of the tower. Well, what happens then, you can cipher off the heavier alkanes at the high temperatures near the bottom, and the lighter alkanes can be ciphered off at the lower temperatures at the top. Therefore, then, a fractional distiller based on temperature variation of the boiling point allows you to be able to separate alkanes. Number 5, is gasoline a compound? If not, what is it? Gasoline is a mixture of alkanes. Therefore, it is not a compound. Gasoline is a mixture of the alkanes, A-L-K-A-N-E-S. And I expect you to know all of these basic alkanes from methane, C4H4, all the way up to decane. All right, but gasoline is not a compound. It is a mixture of alkanes. Number 6, why are structural formulas more important in organic chemistry than in inorganic chemistry? The reason is isomers, I-S-O-M-E-R-S, I-S-O-M-E-R-S, isomers. So isomers are chemical compounds that have the same chemical formula, but have a different arrangement of the atoms between the carbon and the other atoms that's present. That's the main difference. And because they have a different arrangement of the same number of carbon and the same number of hydrogens, the different arrangement calls for different properties. Therefore, we need these structural formulas so that we can see the various structures that we have. Number 7, isomers of a compound have the same chemical formula. In what ways do they differ from one another? I just answered that with number 6, is that they have different properties. They may they have different boiling points, although they have the same chemical formula, same molecular formula. They have different physical and chemical properties. Therefore, they will be distinguished. Number 8, distinguish between, do I have 8 on the list? No, 8 is not on the list, so I won't give that. I'll go to 9. How many electrons are shared in a double bond between 2 carbon atoms? So we have 3 types of bonding that we can have. We have single bond with just 2 electrons being shared. We have double bonds with 4 electrons being shared. And we have triple bonds with 6 electrons being shared. Therefore, the answer to this question, how many electrons are shared in a double bond between 2 carbon atoms? The answer is there are 4 electrons shared in a double bond. And lastly, number 10, what kind of carbon-carbon bonds are found in alkane molecules? Alkane molecules only have single bonds. As we said, you can have alkanes, you can have alkenes, A-L-K-E-N-E, and you can have alkynes, A-L-K-Y-N-E. The alkynes have at least 1 triple bond. The alkenes have at least 1 double bond. But all of the alkanes, A-L-K-A-N-E, have only single bonds. All right, young people, that's what I wanted to share with you. Get your homework in then for chapter 13, both the multiple choice and the exercise that I've given you some suggestions here, okay? Contact me if you have any questions. Have a good day.